Hello, good morning or good afternoon. My name is Saman Montalvo. I am a PhD postdoctoral research fellow at Stanford Medical School, Stanford University, part of the Woodside Human Performance Alliance. Today I'll be talking about Taijiquan Science. We're going to talk about two main projects, one in clinical settings and another in sports sciences. These two projects are one is the effects of 12-week Taijiquan exercise training on balance, gait, speed, and quality of life with individuals with Parkinson's disease, a pilot study. And the second one is a construction of normative data for vertical jump performance with Malaysia, Taijiquan, and Talu athletes. And we're going to talk about future directions for these two research studies. First, the Taijiquan and boxing study with individuals with Parkinson's disease. This is a pilot study once again. We know that Taiji can be used as an alternative form of exercise during physical therapy or any physical activity in clinical and non-clinical settings. Moreover, we know that there's been a lot of benefits shown in the literature when using Taiji in terms of quality of life, speed gait, and overall physical performance. However, data so far is not conclusive when comparing to other exercise forms of therapy. Therefore, our pilot study aimed to compare the effects of Tai Chi and boxing. It is just a pilot study, and it was conducted with collaboration of Mood Therapy and the University of Texas at El Paso. This was again conducted out of El Paso, Texas. Um, this was a internal research study using retrospective analysis. Participants were re-enrolled in their own regular physical therapy sessions for 2 times a week. Uh, we added 1 hour of boxing and Tai Chi Chuan or 1 hour of Tai Chi Chuan exercise for each class. Typically, we had 5 participants per class. So we ended up having at the end, we had 10 subjects that we aimed to track over time, but we only got 5 participants to finish the whole project. One of the reasons for this was that we still have some cover restrictions. Some people were missing sessions because they didn't feel well. So they were not so much due to the exercise sessions, more they were due to other external conditions that we were unable to account for. Two of the major exercises that we tracked or physical test to see if they improve or they did not improve their physical performance was one, the very standard 30-second chair stand test, which typically is a person just sits on the chair and then they go up, they get up, and then they get down as fast as they can for 30 seconds. It's kind of like a squat test. Again, in the picture, you see like the person has their hands on their shoulders, and without using the arms or torso, they try to go up as fast as they can, up and down. It's mainly lower body testing exercise. Again, then a score is given depending on their age and then their sex. The second test is a time up and go test. We can see on the right side the person is seated, and then we see a time watch, and then the physical therapist or whoever is conducting the test will say ready, set, go. The person will get it go up and then walk across around the cone, and then they'll go back to the sitting to the chair. This again is a measure of gait speed and change of direction because they have to go across the cone. Some of the results we see from pre to post. We see several colors and several lines. Let's talk about the first on the left side. We see on the second plot we see 5 points. Each one of those belongs to each individual. We label this as BT. So BT1, 3, 6, BT9, and BT10. 1, 3, and 6 are going to be your Taiji participants, and then 9 and 10 were boxing participants. And then We see from pre to post on the 30-second chair stand test, we want to see those numbers to increase, right? Because we want to see body strength improving. So we see BT1 way in the bottom next to number 10. We see from pre to post increases. It was around 10 to almost 11. So we do see a nice improvement. We do see BT3 almost in gold, almost around the number 13. It also increased from 13 to almost 15. Then lastly, BT6, or another Taiji study on the 30-second chair, that person decreased slightly. So we see two Taiji athletes improve and then one decrease. Taiji 9, BT9, which is a boxing athlete on blue, we see that person almost on 16.5. That person remained about the same from pre to post. So no change was observed. BT10 on purple, we see that a number close to number 14. We see that person pre to post to stay around the same level. So we see that boxing did not make any change on the 30-second share stand-up test. Now moving to the right side, we have our time up and go test. We see that again on this, we want to see the time to go around the cone to decrease. That's going to indicate that a person is moving faster and in a more controlled manner, and they're able to go around the cone very nicely. So we want to see those numbers to decrease, contrary to the 30-second chair and stand up, where we want those to increase. So again, we're looking at decrease on these values. We can start on BT1, which is the orange. We see that close to 10.5 and decreases all the way to like almost 9 from pre to post. In gold, again, we see similar trend from 9.5 to almost 8.5. And then on green, we see as an increase on BT6 from 8.5 to almost 10. So we see that our Taiji improved in 2 athletes, but not in 1 athlete or 1 participant. We don't know the reasons for that yet. So that's something to consider for our for future full study. And then we see for on the blue BT9, we also see a massive decrease for that boxing athlete or participant from 8.2 to almost 6.4. Lastly, on purple, a BT10, we see that from 10 going all the way to like 8.5. So we see that boxing, it did improve the time up and go test. So our results, we see on the right side, we see our table with our descriptive statistics, our mean standard deviation, and also mean, median, mean and max. Again, we only have very few participants, so most of this are not going to be that very relevant, but at least it gives you a framework to have when we include more participants. But again, we can at least see some numbers changing. Our Taiji group, it only improved for about 5.2% for all those 3 participants from pre to post, and the 30-second share test, and then 5.4 on the up and go test. Boxing group had about 26.7% improvement in the time up and go test. So again, this could be an error, maybe a measurement error, or it could be something that we need to improve to make sure we capture the correct test. Something that we need to clarify is that we only took 1 test, 1 measurement, 1 time they did the test. So in order for us to improve this in the future, we're going to add 2 separate testing sessions, so we can do a reliability analysis between those time periods, and we can get a more accurate representation of the actual baseline value for the individual. So we don't get with this huge improvement that might be an error, maybe a performance error for the person, but it's something that we need to be careful of. Again, this was just a pilot study, but at least it gives us a framework and a reference to work from. So some of the future directions, obviously we need to increase the sample size. We were aiming for 10 individuals, but like I stated, because of the still COVID restrictions and the flu and so many other external conditions, we were unable to keep those 10 participants over the 12-week exercise testing session or pilot study. We need to improve retention strategies. We try to talk to people what they thought about the class, the Taiji classes and the boxing classes. They love both of those exercise training modalities. But again, we lost some people due to they never told us why they never actually returned. We tried to contact them, but the never replied to our calls. So we need to maybe improve some of our rotation strategies. Lastly, we want to register and apply for a randomized control trial so we can have this clinical study done properly and maybe seek for future publications and funding. The second project is going to be on Taijiquan, more in sports science based. We know that Taolu or Wushu is more modern. Wushu is more of a dynamic, explosive, competitive sport, if you will. And because of this, we know that a vertical jump or just jumping can be used as a proxy for muscular power and explosiveness assessment. Currently, there's very little research in wushu athletes and the physical performance measurements. So we're aiming to start creating different normative data sets for all the wushu athletes, whether this is wushu, taolu, or sana. Some of our prior studies from my colleagues aim to do this to start showing descriptives of strength and power measures with the Malaysia elite wushu team. For example, we see this athlete is standing on two force plates, and those force plates, as a person jumps into the force plates, those force plates are going to measure ground reaction forces, which the time and position from the force plates can give us a ton of kinematic and kinetic measurements, such as force, power, velocity, impulse, and so on and so forth. So again, this is something Eric Tan, a colleague of mine, produced in 2017. But as we can see on the top, we have three columns: one from Nanquan, Changquan, and Taijiquan. We see Nanquan has 4 athletes, 2 females, 2 males. Changquan has 4 and 4, and then Taijiquan has 2 and 2. So we only have very few, it's a small sample size. So it's very hard to create a normative data set out of this descriptive study. So this led to to us attempting to create a new a normative data set for this. So for this study, we had 110 athletes participating at the SUKMA, the Malaysia Games in 2022. In this cross-sectional trial, this was a month ago, and athletes jump into uniaxial force plates where we capture the vertical jump performance as well as kinematic and kinetic properties of the vertical jump. Athletes performed 2 trials of the vertical jump with hands on hips, just like I showed in the picture. Athletes was with the hands on hips, and then they performed the vertical jump. The average of these 2 jumps was used for the initial analysis and the creation of normative data. Then normative data set that was created using the T-scores derived from the C-scores, and similar to previous research on other sports. Then differences among the groups. So we have Nanquan, Changquan, and Taijiquan. We wanted to see if they were different. We use just a standard one-way ANOVA. All data was analyzed in R Studio using R programming language. So here's our initial data analysis. Like each point is going to be each participant. On the right side in green, we have females, and then on the right side we have males. Then we have our distribution plot on the right side for each other box plot, and then the box plot is going to indicate first quartile, second quartile, and then third quartile, and then with over 95% confidence intervals. And then we see there's some difference between jumping ability between the sexes. So we do need to make two normative data sets, so one for females and then one for males, because we do see there's some difference among those. Then lastly, I wanted to see, okay, there's a difference, just maybe we look across, there's just tall events, so Changquan, Nanquan, and Taijiquan. We do see that Taiji on the mean and the medians are just slightly slower on the dark line on the purple compared to Nanquan and Changquan. But once we run the ANOVA, there was very slightly difference on that end. So we wanted to see if we can just do it by events and then by sex, right? So this is what we ended up with. This might not be the most appropriate way to show this at the end, at least for manuscript perspectives, because we have very less participants per group because we're dividing by female, male, and then Chanson, Nanchan, and Tajiswan. But at least we do see that if we look only in the females, we see that the median stays around the same, regardless of the Chanson, Nanchan, and Tajiswan group. And then same for males, it remains about the same. The median for males and females remain about the same regardless of the event. Therefore, we're just gonna stratify by sex, males versus females. So this is what we ended up with at the end of the analysis. The normative data set we have on the right side, we have males, and then on the right side we have females, and then we have broken down this into excellent, very good, good, above average, average, below average, poor, and very poor. Again, this is depending on the number of participants that we have and then the C-score that they get. Again, most people are around the average. We'll get that dark color to it. So this at least gives the athletes a way to visualize where they are according to this scale. Again, this is across the whole Malaysia national athlete pool. So those that might be under the excellent area, or the good area might be towards more of a more advanced athletes, and those are poor, maybe on the lower end. Again, we have to still do those discriminative analysis, but we'll still working on that data. So here's some other more numbers tables. So again, we have almost 110 athletes. We have 110 athletes, and then we obviously stratify by sex and then the events. Again, we don't see a clear difference between jumping events and jumping abilities. On wushu events and jumping abilities. So again, there seems to be no much difference between a Taijiquan athlete, Nanquan athlete, and a Changquan athlete, regardless of the event, right? Again, the only difference was whether they were male or female. Then again, normative data can be used to screen athletes' jumping abilities. We also have to do that discriminant analysis, whether again the jumping can actually discriminate whether they're advanced or not advanced. However, on our end, or just it has shown that on our prior analysis has shown that it does discriminate accessibility, but we haven't done that in this data set yet. Lastly, we want to include athletes from other countries so we can compare across different training levels and different country levels as well. Some of the future directions for this. So we seek to publish this normative data within the next few months. Like I said before, with Eric Tan and my colleague from Malaysia, we already have published some articles, which we invite you to read on jumping performance with the Malaysia athletes and from the Americas. So another analysis that we aiming to do for this big data set is to look at the inter-limb symmetries during jumping and jumping performance using machine learning algorithms to see whether if a person is either more balanced on the legs, so whether they push with the same force with the right and left can actually perform better than that one that's a little less symmetrical, using again machine learning algorithms. Then we want to create a worldwide normative data, and we want to collect data next year at the World Wushu Championships that's going to be held in Dallas in the United States. I believe it's around November next year. We're still working on the IRB and the logistics of it too, so we can collect data. And then we want to expand that just not for the tall athletes, but we want to include some athletes so we can have a nice wide pool of athletes. Lastly, we want to do this data set open access. So we want that data set just to not stay with us. We want to also make it shareable to everyone who wants to play with the data. And again, as long as we conform with IRB rules and privacy and all that, right? But we also want to give back to our Wushu community. Lastly, our acknowledgements. Big thank you to my colleague Eric Tan, who is a sports scientist and coach at the Malaysia National Sports Institute. To Dr. Catherine Reyes, who is a DPT and PhD student at the University of Texas El Paso, who is collaborating with me